All right, here we go. So first things first, we are going to get into kind of starting a little bit of review today. This isn't necessarily the review sheet, but getting into a little bit of kind of a review activity. So what I have here is I have a product that is real. They made it. They sold it. It's called a Miracle Thaw tray. Okay. And when you open it up, it's obviously very old. The infomercial is even greater. When you open it up, okay, you get yourself a tray. And we'll talk about what it's made out of and stuff like that in a second. But what I want to do is, I'm not quite sure. Usually I have everybody touch it. Maybe I can do that with the wipes. But so I have the little infomercial. So Miracle Thaw tray. Put that right there. Mr. Duchant, will you hit those lights real fast? So here is the actual infomercial from the good old 90s with the Miracle Thaw tray. Let's see what it's all about. Okay. Oh, heavens, fancy Lou. Start.
Introducing Miracle Thaw, the incredible new defrosting tray that perfectly thaws frozen food like magic in just minutes. No chemicals, no batteries, no wires. Look, this thick steak could take all day to defrost, but just place it on Miracle Thaw and in 30 minutes it's butcher block fresh. Amazing. Just watch what happens to this ice cube. The secret is in the superconductive metal. It absorbs the natural heat from the air and releases it into the frozen food. The tray is cool to the touch, but the cube melts like it was on a hot griddle. Microwaves give you dry cooked edges, causing stale flavor. But these rock-hard chicken breasts are moist and tender in just 12 minutes. Now, defrost any meat or fish in no time. Food always thaws cool and juicy for the best flavor. You'll be amazed how fast you can go from this to this with Miracle Thaw. Use your credit card and call toll-free 1-800-729.
Perfect. Okay, well, you're not really going to order it. But so it's called a Miracle Thaw tray. Thank you there, Mr. Duchant. You can put that back on. So the idea is that it is, okay, made out of a metal. It said space-aged metal. Yeah, okay. But the big idea is it says it has no electricity, no chemicals, no batteries, no microwave. All it does is defrost your food. And the little thing, you always got to check it. The little thing they did with the ice cube. Let's try that. So I have a Miracle Thaw tray here. And I also have a piece of wood here. Now, when I put my hands on this, let's have somebody do that. I want you to put one hand on each of these. Right here and right here. What does this one feel like? This one's cold. Okay, the Miracle Thaw feels very cold to the touch, and the wood feels warm to the touch. So I want you to think about that. And then what they also did was this lovely little ice cube test. I have 2 ice cubes. They're the same size. Okay, and we're going to do what they did. We're going to put 1 ice cube over here, and we're going to put 1 ice cube here to have a control. And you saw it pretty much melted really, really quickly. And if you can kind of see here, hopefully my people at home can see it. I'm going to carry this around. Okay. This is actually melting very, very quickly. It's already kind of got a big puddle of water coming around it. So as you can see here, I'm going to walk around here. Okay. They were not pretending that was going to happen. We have our ice cube is very much melting very quickly. It's already in a puddle of water here. Miracle Thaw, beautiful. It is melting that ice cube very, very quickly. Okay, awesome. So how can this be cool to the touch? Oh, and I got water all over myself. But also, okay, melt that ice cube. As you can see on my wooden tray, it's barely melted at all. Okay, putting that there. But on my Miracle Thaw tray, the ice cube's almost gone itself. It is very, very quickly melting there. Okay, so what I want you guys to do, this is kind of the background that you would get. I would like for you to talk about the Miracle tray felt cold when you touched it. Do you think the tray and the wood are at any different temperatures? Then I want you to explain then the difference in temperatures. If you want to draw, you can. Then for number 2, the 2 ice cubes of the same mass were used. Observation for number 2, you can just say, as you can see, the ice cube on this tray is almost completely gone here, almost completely gone. Whoops. And then the ice cube here, still living Still there, hasn't done much. Okay. Then draw an energy diagram for the Miracle Thaw tray and the wooden block. So draw the Miracle Thaw tray with an ice cube on it, the wooden block, and we can go through all this. Let's do the front, then we'll pause, we'll go over it, and then we'll do the back. Okay, so if this was a test question, thinking about direction of energy transfer, remember everything goes from high to low. Think about what is warm, what is at a lower temperature, all that kind of good stuff. So I'm going to take some attendance. I'm going to give you a few minutes. If this would have been a great test question. So if this was a test question, can you run through and answer 1 through 4, and then we'll go over and we'll do the back. 1 through 4. If you had answered about the Miracle Thaw, what would you say? All right, attendance peeps. Awesome. All right, let's talk about this. So I at least want to go through the first 4 and make sure everybody's feeling good. Because this stuff, it can be confusing, okay? So if you're on the back, if you don't mind, take a pause really quickly. And let's go to the front, because I saw some people that had this backwards, but that is okay. I think when I told you at the beginning of the unit that a lot of people have misconceptions in thermochem, and that's okay. That's why we do this. So the Miracle tray felt cold when you touched it, and the wooden tray felt warm. These two things have been well, now the one has ice cubes on it. But these two things were sitting here since forever. They're both at room temperature. So this feels cold and this feels warm, just like your chair leg feels cold and your table leg feels warm. Are they at different temperatures? No, they are not, okay? Both of these things are at room temperature, okay? So they're the same temperature. So how can one feel cold and one feel warm? Let's go through it. The Miracle Thaw tray is made of what? Metal. And metal is a what? Conductor. The metal is a conductor, so it quickly transfers energy. And the tray is an insulator, so it can't transfer very quickly. Okay? So that's step 1. It's all about what it's made out of. Okay. Now, the 2 ice cubes we had, just whatever your observation, the tray melted the ice cube very quickly, the wooden block, and they're about the exact same mass. Okay, this is heavy mass here. But this guy, ice cube's still sitting there. Man, he's not going anywhere real quick. And the tray, the ice cube's been gone for quite some time. Let's talk about why. Here is where I see most of the misconceptions. What temperature is an ice cube at as it melts? Everybody should know that. That is 0 degrees Celsius. Both of my ice cubes were at 0 degrees Celsius. We agree with that. It's an ice cube. It's frozen. Now, people might say, well, this goes in and this goes out. And this, They both give energy the same way. Room temperature. Is it warmer or cooler than freezing in this room right now? It's warmer, right? So it's about a good temperature in Celsius, about 26 degrees Celsius. So the tray is high and the ice cube is low. The wooden block is also high and the ice cube is low. On both of these, which direction is energy going? From the trays into the ice cube. Remember, because everything goes from high to low. So both of them are giving energy to the ice cube. Why did this one melt it faster, though? Perfect, because it's a conductor and it easily transfers energy. This is trying its darndest to melt that ice cube. It just can't because it's an insulator, okay? So that is a big misconception. You want to make sure, this would be a great one to put on a test where you would have to tell me which direction energy was flowing, okay? So I wrote a big, long answer. You don't necessarily have to write this. So the word fact is not miracle. It's not magic. It's not any of that stuff. It's simply that the tray is a conductor. They are both at a higher temperature. So everything goes from the tray into the food, okay? Quickly defrosting it, because usually you just put it on your counter. Your counter is an insulator, so you can put hot things on it, and it resists the transfer of energy. This is just a conductor, and it quickly transfers the thermal energy into the food and melts it, okay? So that was the front. I'm going to give you a few more minutes. You got some math on the back. Got to love to practice some math. If you're thinking about Q is equal to MC delta T on most of these, you should be good. All right. Can I have 2 ice cubes of a different mass and try one on the metal and one on the wood? The direction says that a person should take the tray, okay, and to make it go even faster, you're supposed to put it in warm water first, and then you put your food on it. Talk to me about why that might be good. Talk to me in joules, more joules, less joules. Here is a Q is equal to MC delta T problem. I want to know how much energy is transferred into the food. Law of conservation of energy here. You got on 8. And then number 9, this would be a fantastic thinker question. They finally let you know that this is made of aluminum. Aluminum. Same stuff as this. So thinking about it, could you just get out one sheet of aluminum and put your meat on that? Would this freeze it, or will this thaw it as well as this? It's the same substance. I want you to think about what might be different between these two, though, okay? So I'm going to put the music on quietly, give you another few minutes for that. We're going to go over it, okay? So hopefully here on the back, you got 4 more questions on the back. Answer those. Coming around, seeing how we're doing. 4 more questions on the back. All right, let's take a moment to go over it. I see some people still writing, but I think we got a lot of people that are ready to take a look-see and see how you did on this guy. All right, number 1, could I have used ice cubes that have a different amount of mass? So always you want to be thinking about is Q is equal to MC delta T. If I have a giant ice cube, a big ice cube, is that going to need a lot or a little bit of energy in order to melt? Big ice cube would need a lot of energy, right? So it wouldn't be fair to put a humongous ice cube on this conductor and a teeny tiny ice cube on this one and say, oh, look, they can't melt them the same. This doesn't work. You have to keep that mass the same, okay? The mass is very important because if you bump up the M, that's bumping up your Q for sure, okay? So kind of just, if you think about mapping that, it would be unfair. You couldn't compare them. There should be a P in there. Whoops. Okay, it takes more energy to melt a more massive ice cube. Okay, all right, so the directions state that a person should preheat the tray with hot water. So if I take this and put this under hot water for 30 seconds, what are you going to do to the temperature of this thing? Yeah, it's going to go up. Then if I think about my Q is equal to MC delta T, if my temperature has gone up, what's that going to do to the amount of Q in here? It's also going to go up. So if I have, because the mass is still the same, it's still the same C, but if I preheat this and I put more energy into it, it's going to have more Q, and then therefore it will be able to transfer even more energy than even just at room temperature, okay? So if you preheat the tray, you make it hotter. That gives the energy, or the more Q to the tray, allowing it to transfer even more energy. Okay, very good. Very, very, very good. All right, so this was a lovely little math problem. The total mass of the Miracle Thaw tray was measured to be 870.42 grams. Put that for the M. It's aluminum, so it says specific heat capacity is 0.9. Whoops. Multiplied by, okay, it went from 52 to 0, so that's 52 degrees. If you're trying to find Q, hopefully you got a good number there. Did you get a little different than me? Did I have, this might be my 0.90. Let me get it. This is 6.9 times 870.42 times. So yours should be 7035.
I got 40735.
Yep,
Yeah.
735. 0.65, if you will, 66, depending on how you round. Boom. All right, wonderful. Okay, now the question is how many joules of energy are then going into your food? And the answer to that would be the exact same amount because of the law of conservation of energy. So I'm just going to take this number, clone it right down there. There we go. Okay. Last one, and I love this. I was walking around reading people's here. Could I just use, this is the same stuff. I could paint this black. Would this melt the ice cube the same? Why not? More metal. Perfect. If I'm looking at Q is equal to MC delta T, again, if I have more M, I have more Q to deal with. Okay? Perfect, guys. That's awesome. The masses are not the same. Okay? This would give away a little bit of Q. This gives away a lot of Q. So these are not going to melt anything. They might be the same material. They have the same C. I get that. Okay. They might be the same temperature. I get that. But if you rocket up your M, you get so much more Q. And therefore, this will melt anything way faster, even though it's the same stuff. Okay. Perfect. I'm glad you guys really saw through that. That was really, really, really awesome. M matters here. Okay. So what we're going to do, we have about 5-6 minutes left. You're going to get into your post-lab questions, which you are your post-lecture questions. If you have not done those, I saw some people that did. We have the concept map we'll talk about tomorrow. If you would like to take the last 5 minutes, start to look over the review sheet. Okay, I'll give you time tomorrow to finish it and ask questions. So, but in the last couple of minutes here, you're going to get into the week 12 Tuesday folder, do your lecture questions, and then start taking a look at the review sheet in here. Okay. Tomorrow is the review day. Thursday is a lab for you guys at home, just another day to review. And Friday is the final test for this unit. Good stuff. I'm going to walk around and see how everybody's doing. Maybe I'll check in with the peeps at home, see how they're doing too. Questions or concerns. Turn the camera. Stop recording.